Hello and welcome back to Chopstick Maths Differential Equations PYQs, previous year questions. June 23, solve the differential equation d square minus 4d plus 4 into y is equal to e raised to 2x plus cos 2x. The general form of this equation is f of d into y is equal to capital X. Now the solution to this differential equation is of the type y is equal to the complementary function plus the particular integral. That is, the solution has two parts, complementary function and particular integral. So let us first calculate the complementary function. Now to calculate the complementary function, equate f of d is equal to 0. That is, d square minus 4d plus 4 is equal to 0, and this is known as the auxiliary equation. On solving, we get the roots of this auxiliary equation are d is equal to 2, 2. Now the roots are rational and repeated. So the complementary function will be c1 plus c2x into e raised to 2x. Now let us proceed to calculate the particular integral. Pi is equal to 1 upon f of d into capital X. Therefore, pi will be equal to 1 upon d square minus 4d plus 4 into e raised to 2x plus cos 2x. Now we can write this in this form. Pi is equal to 1 upon d square minus 4d plus 4 into e raised to 2x plus 1 upon d square minus 4d plus 4 into cos 2x. That is pi, we can write it as pi1 plus pi2. We can break it into two parts and we can solve it individually. Now let us first calculate pi1. pi1 is equal to 1 upon d square minus 4d plus 4 into e raised to 2x. Now here a is equal to 2. So f of d is d square minus 4d plus 4. Therefore, substituting d as 2, we get f of 2 is equal to 2 square minus 4 into 2 plus 4. That is, f of 2 is equal to 0. So f of 2 is equal to 0. So we shall now proceed to calculate f prime d. That is the first derivative of d, which is derivative of d square is 2d, derivative of minus 4d is minus 4, and derivative of 4 is 0. So f prime d is equal to 2d minus 4. Now substituting d as 2, we get f prime 2 is 2 into 2 minus 4 is equal to 0. Now we see again f prime 2 is 0. Therefore, we shall now proceed to calculate the second order derivative f double prime d. Now f double prime d is the derivative of 2d is 2 and the derivative of minus 4 is 0. So f double prime d is equal to 2. Therefore, substituting d as 2, we get f double prime 2 is equal to 2. Now you see f double prime 2 is not equal to 0. Therefore, pi will be equal to x square into e raised to 2x upon 2. Now let us calculate pi2. pi2 is 1 upon d square minus 4d plus 4 into cos 2x. Now here we can substitute d square as minus 2 square, as a is 2. Therefore, pi2 will be equal to 1 upon minus 2 square minus 4d plus 4 into cos 2x. Therefore, pi2 will be equal to 1 upon minus 2 square and plus 4 will cancel out each other. So, pi2 will be equal to 1 upon minus 4d into cos 2x. Therefore, pi2 will be equal to minus 1 upon 4 into 1 upon d into cos 2x. Now, here 1 upon minus 4d, we can write it as minus 1 upon 4 into 1 upon d into cos 2x. pi2 will be equal to minus 1 upon 4, and we know that 1 upon d is the integral. So this will be integral of cos 2x dx. pi2 will be equal to minus 1 upon 4, and we know that integral of cos 2x dx is sin 2x upon 2. So pi2 will be equal to minus 1 upon 8 into sin 2x. Now pi is equal to pi1 plus pi2. Therefore, pi will be equal to pi1, which is x square into e raised to 2x plus 2, and pi2, which is minus 1 upon 8 into sin 2x. So pi will be equal to x square e raised to 2x upon 2 minus 1 upon 8 sin 2x. Therefore, the complete solution to the differential equation is y is equal to the complementary function cf plus the particular integral pi. That is, y is equal to c1 plus c2x into e raised to 2x plus x square into e raised to 2x upon 2 minus 1 upon 8 into sine 2x.